to our today's lesson on chemical families. Elements in the same group have similar chemical properties because they have the same number of electrons in the outermost energy level. Elements in the same group belong to the same chemical family. So, if you remember what we talked about when we were talking about the periodic table, we said that elements are arranged in groups and periods. Now, in chemical families, we are going to discuss about groups. There are some groups which have been given some chemical families, and these ones are the ones we are going to talk about in this topic. And elements in the same group have similar chemical properties. And the reason is because they have the same number of electrons in their outermost energy level. So, let us go ahead and see which families are these. There are 4 chemical families in the periodic table. We have group 1 called the alkali metals, group 2 called the alkaline earth metals, group 3, no not group 3 but group 7 called the halogens, and then we have group 8 which constitutes the noble gases. Let us talk about alkali metals. These are elements in group 1 of the periodic table. They include lithium, sodium, potassium, rubidium, cesium, and francium. They have 1 electron in the outermost energy level and are therefore said to be monovalent. A table showing the chemical family of the alkali metals is as shown below. We have the element lithium, the chemical symbol Li, the atomic number 3, the electron structure 2.1. Electron structure, I had earlier told you that is electron arrangement or electron configuration. Sodium with the symbol Na, atomic number 11, electron structure 281. Potassium, symbol is K, atomic number is 19, the electron structure is 2881. We have rubidium, cesium, and francium. Now, these ones are not among the first 20 elements of the periodic table. We are just mentioning them, but we shall not look at their chemistry at this level. Physical properties of alkali metals. They have a metallic luster, that is a shiny surface when freshly cut. Good conductors of heat and electricity. They are soft and easy to cut with a knife. They have relatively low melting and boiling points due to the weak metallic bonds. Then they are less dense than water. They float on water when placed in water. Trends in physical properties down the group. Alkali metals have relatively low melting points and boiling points. The melting points and boiling points decrease down the group due to decrease in strength of metallic bonding, which increases with increase in metallic size. Another trend is ease of cutting increases down the group due to the decrease in the strength of metallic bond with increase in metallic size. Atomic masses increases down the group due to increase in number of protons and neutrons. As we go down the group, there is an increase in the number of protons and neutrons. Hence, this increases the atomic masses. The atomic radius and ionic radius increases down the group due to increase in the number of occupied energy levels. As we go down the group, there is an increase of 1 energy level after another. Therefore, the atomic radius also increases as much as the ionic radius increases down the group. The atomic radius is greater than the ionic radius because the alkali metals react by losing the outermost electron, hence their ions have one less occupied energy level. The ionization energy decreases down the group due to increase in atomic radius, which decreases the force of attraction between the outermost energy level, the outermost electron and the positive nucleus. Now, we know ionization energy is the minimum amount of energy required to remove an electron from the outermost energy level of an element in the gaseous state, of an atom in the gaseous state. So as we go down the group, it decreases because electrons are not closely held by the nucleus as when they are near the nucleus. Therefore, it decreases the force of attraction to the outermost electron, hence it can easily be lost. Therefore, ionization energy decreases down the group. The electrical conductivity increases down the group due to the decrease in forces of attraction between the nucleus and the outer electron, which increases in atomic radius, hence the electrons are more localized. Therefore, we know electrical conductivity is as a result of the localized electrons. Therefore, as we move down the group, there is the force of attraction between the nucleus and the outermost electrons will decrease. Therefore, this enables the electrons to be more delocalized, hence conduct electricity easily. Thank you so much for being alert in my lesson. Hope you've learned something. Welcome again to our next lesson. Thank you. Bye. Cheers.